All right, in this video we are going to talk about the trig functions. Things we do know right off the bat are the derivative of sine x equals cosine x, right? And the derivative of cosine x equals a negative sine x. So for this first sample problem, basically you're taking a term at a time when you do the derivative. So dy dx, the first term, the derivative of 5 sine x will be 5 cosine x. The second term, the derivative of 3x to the third, and I still have my minus there, will be 9x squared, right? Then the derivative of 2 cosine x will be 2 negative sine x. So I'm going to bring this negative out here and say 2 sine x. And then the derivative of 4e to the x is just 4e to the x, right? Okay, let's look at this one. We can rewrite this to make our lives easier as those mean the same thing, right? So dy, in this case d theta, this is part of the chain rule, remember? First I'm going to take the outside, which will be 2 sine theta to the first times the derivative of the inside, and the derivative of sine is cosine. So that's our answer there. All right, here are these sample problems. Let's look at the first one. This again is using our chain rule. We take the derivative of the outside and then the derivative of the inside. Dy dt. Okay, the derivative of sine is cosine, right? So this will be 5 cosine of 3t squared plus 2t. Then we have to take the derivative of the inside here, which is 6t plus 2. All right? Let's look at this one. Now we're using both the chain rule and the product rule. So the product rule is f prime g plus fg prime, right? So dz with respect to theta. First, the derivative of theta itself is just 1, isn't it? So 1e to the cosine theta plus f times the derivative of g. Well, e to the cosine theta is going to be e to the cosine theta. Now we have to do the derivative of the inside, the cosine. Derivative of cosine is negative sine of theta, isn't it? So we could rewrite that as e to the cosine theta minus theta sine theta e to the cosine theta, right? All right. This next one, you're actually proving or deriving the derivative of the tangent function. We're going to treat it as sine x over cosine x. And we need to use, looking for my page that I did this on, we need to use the quotient rule, right? At the top here, the quotient rule is f prime g minus fg prime all over g squared. All right, let's start this out. Okay, f prime, the derivative of sine is cosine, so it's going to be cosine x times g, which is cosine x, right? Minus sine x times the derivative of cosine x, which is a negative sine x, isn't it? All over cosine squared x. So what I can really say is, if I come down here, this will be cosine squared x plus sine squared x all over cosine squared x. Well, if you remember a Pythagorean identity that said sine squared x plus cosine squared x equals 1, right? So this becomes 1 over cosine squared x, which is the same as secant squared x. So we were just deriving the derivative of the tangent function. I think from now on you can just say this or this, depending on what you're going to use it for. All right, see here we're going to use this particular part of it. So let's look at this. All right, so the derivative of sine x tan x, we're going to use the product rule, right? We know that derivative of tan x is this. So here's what we're going to get. Product rule. The derivative of sine x is cosine x, right? Cosine x times tan x plus f times the derivative of tan x, and they're saying use 1 over cosine squared x, right? Well, cosine x and tangent x can be written as sine x over cosine x, can it? So those two will go away. And then this will be plus sine x over cosine squared x. All right. Well, sine x is a common term. I am going to pull that out or factor it out. And I'll have 1 plus 1 over cosine squared x, which can be written as sine x 1 plus secant squared x. So that's just a sample problem, right? All right, let's try these other sample problems. Remember, we're using, lots of times we're using the chain rule, we're using the product rule, we're using the quotient rule. In this case right here, we're going to use the chain rule. We got an inside there, don't we? So if we say the derivative of g with respect to z, first, the derivative of tangent, which we know is secant squared of our x, which is this. And then we take the derivative of the inside, which is just e to the z, isn't it? So this is our answer right here. Secant squared e to the z times e to the z. Okay, here, again, we're talking about rules. Because this one is inside, this is like a composite function, we would use the chain rule here, right? We'd have to take the derivative of sine first. So the derivative of sine, so this would be, derivative of sine is cosine, so it would be cosine, right, of tangent x times the derivative of tangent, which is secant squared x. Now down here, it's a product rule, right? This is just a product rule. And this is what we did on the last page, where we ended up with, let me go back. That's what we did right here, where we ended up with sine times tan. Yeah, this is the product rule, isn't it? And we ended up with sine x 1 plus secant x squared. Okay, so I went through all the sample problems on his worksheet for the trig functions. I hope this helps.